Take a deep breath. Right now, your lungs are filling with an invisible, odorless gas that makes up 78% of the Earth's atmosphere. We are completely submerged in an ocean of it. Yet, if you tried to survive on it alone, you would suffocate in minutes. It is the ultimate paradox, the explosive force behind the world's deadliest weapons, and the essential building block that allows the Earth to feed 8 billion people. Welcome to nitrogen. On the periodic table, it claims atomic number 7 and the symbol N. It sits firmly at the top of group 15 and period 2. As a nonmetal, nitrogen is fundamentally a gas at standard room conditions, setting the stage for the highly reactive elements that follow it on the table. If we look inside a standard nitrogen atom, we find a tightly packed nucleus of 7 protons and 7 neutrons, surrounded by 7 electrons. But its behavior is entirely dictated by its outer shell, which holds 5 valence electrons. To reach stability, 2 nitrogen atoms will lock together, sharing 3 pairs of electrons to form a diatomic molecule, or N2. This triple bond is one of the strongest connections in all of chemistry, making elemental nitrogen incredibly stubborn and hard to break apart. In its natural state, nitrogen is a colorless, odorless, and tasteless gas. It is famously inert, meaning it prefers to ignore other elements rather than react with them. But drop the temperature to a freezing minus 196 degrees Celsius, and it transforms into liquid nitrogen, a boiling, hyper-cold fluid used across global industries. Chemically, breaking nitrogen's triple bond requires massive amounts of energy, like a lightning strike. But once broken, it forms highly reactive and powerful compounds, such as ammonia and nitric acid. The discovery of nitrogen is a tale of deduction. In 1772, a Scottish physician named Daniel Rutherford trapped a mouse in a sealed jar until it consumed all the oxygen. After removing the carbon dioxide, Rutherford was left with a mysterious gas that extinguished flames and suffocated animals. He called it noxious air. Shortly after, the great French chemist Antoine Lavoisier named it azota, a Greek word literally meaning no life, a highly ironic name given what we know today. Far from meaning no life, nitrogen is the very reason modern life exists. Through a miraculous industrial feat called the Haber-Bosch process, humanity learned to rip nitrogen from the air and turn it into synthetic ammonia for fertilizers. Without this, half the global population would simply starve. On the flip side, because nitrogen desperately wants to return to its stable gas form, nitrogen compounds are highly volatile. This makes it the core ingredient in almost all commercial and military explosives, including TNT and gunpowder. Biologically, you are built on nitrogen. It is a critical component of amino acids, meaning it forms the proteins in your muscles and the DNA inside your cells. However, our industrial use of it has created a severe environmental crisis. Excess nitrogen fertilizers wash off farmland into rivers and oceans, feeding massive toxic algal blooms. These blooms strip oxygen from the water, creating vast dead zones where marine life cannot survive. Furthermore, burning fossil fuels releases nitrogen oxides, leading to smog and acid rain. Historically, nitrogen commanded global empires. Before we could pull it from the air, nations fought wars over natural nitrogen deposits, like bird guano and saltpeter from South America, just to make explosives and grow crops. Today, the geopolitics of nitrogen are tied to energy. Because the Haber-Bosch process requires massive amounts of natural gas, a country's ability to produce cheap fertilizer, and thus ensure its food security, is directly linked to its fossil fuel reserves. From the DNA twisting inside our cells to the explosive power that reshapes mountains, nitrogen is an element of extremes. It is the invisible giant of the periodic table, quietly resting in every breath we take, yet holding the power to sustain humanity or destroy it. Without the next element, life stops in minutes. Oxygen.